Welcome! In this project we will create a magnifier app where you choose a picture of your choice and you can create this box here that will magnify it and show it in much greater detail. So for example, you might choose a high definition picture of a piece of art like this, and the user of the app can explore different sections of it and see it in a higher scale. Or you might find a high resolution scan of an old magazine, and this can be sort of like an archiving service where you can go through and read the text that's a lot smaller, maybe not visible unless you use the magnifier. Or you might like to find a high resolution map, such as this one of Australia here, where you can use the magnifier to look at more detail at specific areas. Like here we might have a look at Sydney or Canberra or Tasmania. Now, before we get started, I would like to say that this is based off an example project by Rice University and their Python programming course on Coursera. So thank you very much to them, and then let's get started. So again, as per the other projects, we'll use Code Sculptor 3. So if you Google for Code Sculptor with a K instead of a C, Code Sculptor 3, and click on the link here, it will take you to this really fantastic online Python interpreter, which crucially has a graphics library built in. Now, as usual, there's some starter code here, or we might call it boilerplate code that most people will need. We won't need all of it though, so let's take out the comments here. We definitely do want to import the simple GUI library, because that will let us create these graphical windows, and we need one of those. We won't need the message, so we can delete that. We won't need the click handler yet, we'll make one later. The draw function for the moment, let's just keep it empty, but in Python you can't keep it empty, so we'll click pass, or we'll type pass, and we won't need to add a button to ours. So just to go through what the code here does, is we import the graphics library, we then make a function and call it draw, and this function we will later on tell the computer to run this about 60 times a second. We then make a frame, and the frame is this, and we call it home, but we can call ours magnifier or something similar. We have a width and a height. We'll change that later because it'll depend on the picture that you use. We then take the frame and set the draw handler to the draw function. This is basically telling it, hey, whenever the screen's ready to redraw, use this function. So these two names have to match up. Whatever we call it, we call it draw canvas or something like that, but those two names have to match up. And we then start the frame. And just a reminder, we'll be using something called event-driven programming. So our functions will be triggered by certain events, such as a mouse click or a mouse drag in this project. Don't forget to hit save as often as you can. So once you hit save, it will give you a new address up in the address bar, and you should click the star over here to bookmark it. Or you could copy and paste it and keep it somewhere safe. But you can't log into this website, so you need to keep that very, very safe so that you don't lose it. Every time you make a change and hit save again, you will have this number on the end increment from 0 to 1 to 2, etc. So try and remember what number you're up to so you can go back to it, because you probably won't want to change your bookmark every time you save. It is good having all the versions throughout your project in there though, as it'll help you with your reflection later, or if you simply make a mistake and want to go back to a previous version, you can. And finally, just remember it does not autosave, so hit save as often as you can. You have to think about what you would like your image to be. It could be a map, could be an artwork, could be a magazine, etc. And once we've done that, we'll head over to Google. You can change it during the project if you wish, so pick something to start with, and you can change it if you need to later. So I have just done a Google search here for 4K art. You might also like to type in something like high resolution or high definition, and then click on images. If you click on tools, select size and select large, it will filter out some of the smaller results, so you will get something that is more high definition. Keep in mind it still might not be enough though. I've decided to use this picture here, and you'll see it's 3840 by width by 2160 height, or 4K resolution. That's several times larger, or 4 times larger than a standard resolution screen, so it'll look good when we're zooming in onto it. Another thing to consider is that yours might be smaller than this, but if it's less than, let's say, 1500 pixels wide or so, it's probably not a good fit for this project, because you want something that's really going to look good under the magnifying glass, and you want there to be a big magnification for it to be sort of worthwhile. So once you've got your image, right click on it and select Copy Image Address. So back over in Code Sculptor, there are 2 steps to getting the image onto the screen. One step is to load the image, the other step is to draw the image. Now the loading the image happens at the start of the program, and we do that by saving it in a variable. I'm just going to call it image, but you could call it background image or main image or something like that. So I'm going to say image is equals simple GUI dot load image, and then we need the web address of that image in quotation marks, because it is a string. That's the data type of this particular object. So just so you know, things like that, if you don't remember or you don't know how to do something, if you click on the docs and then click on the graphics modules, things like that I think will be in Canvas, because that's the screen that gets drawn is called the canvas. And you'll see here that there is something somewhere called draw image, and there's all sorts of example code here, etc. So you can see here the example code, they've loaded the image, but we also need to, inside the draw handler, we need to actually draw the image every time the screen is ready to refresh. Every time the screen is ready to refresh, your draw function will get called and we can paste it in. I'm going to copy and paste this code, and I'm going to explain what these different numbers are. So here we are in our draw function, and I will make a comment saying draw main image. Again, a comment doesn't run, the computer completely ignores it, but it is just a note for us to be able to organize our code. So if I paste this in, let's go through and let's run that and see what happens. You can see it has drawn the image, but it's come up just in the corner here because the numbers that we have in our case are not really correct. So if you'll remember, in the Google search results, in the bottom right here, it tells you the resolution of your image. So 3840 and 2160. So I can draw here, the second one of these along is how wide the original image is. So if I put in 3840 and 2160, you'll see here in the canvas.draw image, there are these different sets of 2 numbers, and they're inside circular brackets. They're sort of like lists that are immutable, you can't change, and they're called tuples. So the second one of those along is the original image width and then height. So we've put that in. The first one is the center point of the image that we're drawing. Now that is simply going to be 3840 for me, yours might be a different width, divided by 2, because halfway along the width and halfway along the height is the center of the object. Now I'm also going to use 2 slashes here for division, because that will ensure that we get a whole number or an integer as the result. We won't get any decimal places. Okay, so we've got the midpoint of my image. Now again, my numbers will be different to yours probably. And we've got the width and the height of the image. These ones here, this is the center position on the canvas where we draw something, and this one is the width and height on the canvas. So if we run it now, you'll see that the top left is 0, 0, x increases as we go over to the right, and y increases as we go down. So what is going to be the width of our canvas that we're going to do? Well, actually, we haven't worked that out yet, because here we have 300 and 200. But I think the way we should set it up is we should scale down the size of the image. If we make the canvas the same size as my image, it's going to be much too big to fit on the page. So what we're going to do is we're going to create a variable up here called image scale. And this is how many times smaller the width is going to be and the height. So I'm going to set mine to 4.5. If you have a smaller image, you might just set it to 2 or 3 times smaller width and height. But I'm going to set mine to 4.5. And how big are we going to make the canvas? I reckon we make it the size of our image, so in my case 3840, divided by image scale. Okay, so if I had 2, it would be half of that size. If I had 4, it's a quarter of that size. So we have the chance, and we can play around with this number, but it basically means that we're squishing it onto our screen there. So again, over here, we'll say, oops, 2160. Is that correct for my image? Divided by image scale. Okay. Now, the same thing here, that's the width and the height of the canvas. This up here is the width and the height we want to draw the image on the canvas. We want to take up the whole canvas, so this will actually be exactly the same. So let's copy this and paste it in there. And then where's the center of the canvas will be the same thing, but each of them will be divided by 2, just like we did before. So I will scroll over so that we can see all of this, and then I'll scroll back. In the next video, we will show you how to make this simpler, because right now it's a bit of a disaster with all the numbers. But let's just see if it works. That's the most important point. So I'm going to click Run, and you'll see that actually it looks like the whole image is fitting perfectly onto the canvas. And if I wanted to change the scale here, like for example, make it 6, that would make it even smaller. So we have our background image drawing correctly, or our main image drawing correctly on the screen, but having all of these numbers can be a little bit confusing, and it actually makes a lot more sense to name these as variables at the start of the program. So what we can do is we can make a variable for image width and image height. We don't necessarily have to call them exactly that. It's a variable. You can call it whatever you want, but that sort of makes sense to me. So our image width in my case is 3840 and the image height is 2160. But again, yours might be different. Okay, so the next thing after that is to work out how big our canvas is going to be. So, oops, if I make a variable called canvas width and another one called canvas height, and if we make the variables here at the start of the program, we call them global variables and we can access them from anywhere in the program. So the canvas width, if my image is 3840 and let's say the scale is 4.5, that means I want the canvas width drawn 4.5 times less than 3840, and we use division for that. So we will say canvas width, set that to equal image width divided by, and we'll use our integer division again so we don't get decimal places. Canvas width equals image width divided by image scale. And the same thing here for height, image height divided by image scale. And now we should be able to make all of this code down here make much more sense. So here, when we create our frame on the canvas, the first thing we need here is the width, and now we have a variable for this. So canvas width and canvas height. And hopefully our code is now getting much easier to read. And if we make changes to these things, we don't have to make the changes everywhere. All right, next thing here, this one here is image width. This one is image height. This will be the center, so image width divided by 2. And image height divided by 2. And over here, these ones are, we want to draw it for the whole canvas. So the very final one here will be canvas width and canvas height. So this is how big it will appear on the screen. We want it to take up the whole canvas. And the center of the canvas, we want it drawn centered on the center of the canvas. So that'll be canvas width divided by 2 and canvas height divided by 2. Okay, so I will just scroll across in case you need to pause to copy this. But basically we're drawing an image. First comes the name of the image, and we've loaded it in as just image. Then we have the center of the original picture, which is the image width divided by 2 and the image height divided by 2. Then we have the dimensions of the original picture, which is image width and image height. Then we have the center on our canvas of where we want to place it, which is the canvas width divided by 2 and the canvas height. And finally, we have how big we want to draw it on our canvas, which is taking up the whole canvas there. And don't forget, we've also updated this down here when we create the frame to be canvas width and canvas height. Hopefully that code's a lot more readable, and let's see if it actually runs though. And yes, it does seem to have worked perfectly, which is really good. Now I just quickly want to explain this. So we made a lot of changes to the code, but the function of the program actually didn't change at all. We might call this organizing or cleaning up, but the programming term for this is actually referred to as refactoring. So if you refactor code, you basically change it in a way that's more organized, and it's a better foundation for the rest of the code we're going to write, but it actually functions the same way as it did before, or at least very, very similar. Maybe sometimes you might refactor code to make it faster, but it'll still do the same thing. We are going to start working on the magnifier on this square here that allows us to see things at full resolution. Because if you remember, we have a scale here that you've no doubt been playing around with to get a good size on your screen. But when we hover the magnifying glass over, we want the scale to be 1. We want it to be the original resolution so we can look at great detail, read the text, etc. So at its heart, what we're going to do is we're going to draw the image again over the top, but we're going to only draw a very small section of it, and we're also going to draw it bigger. So let's start off by copying and pasting this line, and I might put a comment here saying draw the magnifier window. There we go. And I will paste this code, and let's consider what is going to be the same when we're drawing the magnifier and what's going to be different. The image is going to be the same because we're just drawing the same image over the top but bigger and less of it. But what's going to be different here? Well, we're probably going to need a couple more variables up the top here to help us. So I'm just going to copy and paste these to avoid taking the time to type them. But basically, the magnifier size is going to be the number of pixels wide on the screen that it is. And then the magnifier center is the canvas coordinates where the center is. Now just bear that in mind. The canvas coordinates here of where it is, not how far into the image it is, because the image is much higher resolution, and we'll have to fix that a little bit later. But just to explain the problem, if this is shrunk down a huge amount, 100 pixels in on the canvas, if it's got a scale factor of 3, it's actually going to be 300 pixels into the image. Okay, and we'll go through that in a minute. But the magnifier center is going to be the canvas. We'll just set that at the start to be the middle of the canvas, and then the idea is that you can actually click and drag the mouse around to move it later. Okay, but for the moment, we'll just put it in the center of the image there. Okay, so hopefully you can see that there. Now we're going to basically, when we're drawing the image here, do a little bit of setup as well. We talked about I'll just paste this in again instead of typing. We talked about the source center. So the source image is the image that we got from Google, and the canvas is the actual thing that we're drawing onto. So the source center, as we just said, is going to be the magnifier center 0, which is the first element, which will be the X position, times the image scale. So if the image in real life is actually 4 times bigger, we'll have to go 4 times as far in on the image than we will on the canvas to get its coordinates. Same with the magnifier center 1, which is the Y position times the image scale again. So that'll get a source center. A couple of things to notice about this. Number one is this one is not a list. This one is a list. This one is a tuple, and that we use different brackets, and it's a very Python specific thing. It just means that you can't change it later, and it actually runs a little bit faster. It's a bit more performant on the computer. So how are we going to use this source center with our image? Well, down here, you'll remember that the very first tuple here is the source image that we got from Google, the center position of that source image, okay? And we don't want that to be set at the center of the image. We want that to be set at where the magnifying glass center is. So if we put source center like that, okay, the second thing we want to put here is the source image, how wide and how high it is. But again, we're not actually going to draw the whole image again over the top. We're only going to draw 160 by 160 pixels here in magnifier size. So I'm just going to Control C and say that instead of drawing the whole image width, we're only going to draw magnifier size. Okay, so the third thing is, where is this centered on the canvas? And that is the magnifier center. Oops, whoa. We're having some highlighting issues here. This is the magnifier center that we did up here. And the final thing is, how wide and how high do we want it to be on the canvas itself? And again, that's going to be the magnifier size. Now, if this is making your brain hurt, please don't worry. It does take a little bit to get your head around these sorts of things, but I'm sure once you've finished doing a few of these projects, it'll start to make more and more sense, okay? So that's the code there. I'll drag it over to the left so you can see all of it. We should be able to actually put that on a new line, and hopefully it will still work because it's after a comma. Let's hit run. Yes, and you can see here that it's in the center and it has magnified the center. Hopefully it will work when we start moving it around next video. If it doesn't, we'll know we've made a mistake, but I think this is actually looking correct so far. And I might just bring this down as well, just so that we don't have these ridiculously long lines there. So that's the code we have so far. I'll leave it up on the screen. Hopefully you can get yours to this stage. You might have to mess around with the image scale a little bit for yours because it might be a different size, etc., but you should be able to get it. We want to get it so that anywhere we click on the screen, the magnifier will move to that spot. And also, if we click and drag, it will follow us around all the time. So how do we find out what's happened from a mouse click perspective in our program? Well, if we go to the documentation here, or the docs as they're shortened, go to graphics modules and control objects, you'll see that there are a few things here. Set the mouse input handler. Okay, so I'm going to click on that and I'm going to copy both of those. Okay. And we can go back to our code here. Now, where we set the draw handler, which is a function that will run obviously when the screen's ready to be redrawn, we can also set the mouse click handler and the mouse drag handler. So we're basically telling it the names of the functions that will run when we detect a mouse click or a mouse drag. So what name? I think it's the same function that will run. Doesn't matter whether it's a mouse click or a mouse drag. And I'm going to call mine, what did I call mine in the other one? Okay, I'm going to call mine set magnifier center. So that's the name of the function I'm going to make. And the reason is, whenever we click, we want to set the magnifier to be centered on that click. So we need to then create those functions. I'm going to make mine above the draw handler here. I'll say define set magnifier center. And this function, when it's called back, it's called a callback function. When it's called back by Python, it's going to give you the position, the X and Y position as a list or a tuple, I think. It'll give you the position, and I'm going to write the word pos in there so I can capture that position that's given us. You could write the word position, and in that case, that would be, or you could say, come up with some other name for it, but whatever name you put in there will be, there'll be a variable created for you that will have the position where the mouse is clicked, okay? So for the moment, let's just do a bit of a test. Let's say print pos, and so that this function should only trigger whenever there's a click or a drag, and it should print the position. I'm going to hit save because I always forget to do that. Hit run. Oh, let's bring this over here so we can see the output. Okay, so I'm going to click right up in the top left, should be very small numbers. So 11 and 10, and then I'll click all the way over here, should be a very big X number. And then I'll try clicking all the way down here, and now both of those numbers are quite big. If I click and drag, you'll see that we suddenly get heaps of them, because multiple times a second, probably at the refresh rate of the monitor, I'm guessing it will actually update the position. So probably 60 times a second it will update the position. I'm going to hit reset to get rid of that. And now we need to decide what we want to do. Instead of actually print it out, we want to set the magnifier center to be position here. So I'm going to say magnifier center, and let's get the first element, which is 0, element 0 of that list, and we're going to set it to, with equals, the first element of position, because we're being passed in this position list as well. Then we're going to, well, let's copy and paste this because it's the same, except we're doing the second item of the list, which is item 1. Remember, lists start at 0. So basically, they give us the position of the mouse click. We take the first number, which is the X number, and save it over what our first number is in the magnifier center list, which is the X position and the Y position. And now if I save and if I run that, now every place that we click, it follows us, and if we click and drag, it follows us as well. And this is actually really good because we can now see, if I go over this archway down here, we can actually see that it is working perfectly, which is fantastic. So our program is pretty much done. The only thing that isn't done is, I think, having a nice border around this square here really does make it a lot easier to differentiate between the background and the magnifier section. The final thing we need to do on our program is have a lovely line border around the magnifying glass here. And the way that we draw a line with lots of lines joined together is called a polyline in Code Sculptor. If we go to the docs here, we'll go to graphics modules, canvas, and we should have a polyline. So poly just means multiple or many. And you'll see here that basically you can, well, I will copy and paste the code here from the example into our program. We might have a new comment here, draw the magnifier border, and let's just paste that code. So I've just pasted the code from the docs, and let's see what it does. Okay, so it's drawn this line up here, up the top here, so you can see it has started at point 1020. What that means is 10 pixels in from the left, 20 pixels down from the right, and it has gone across to point 3020, which would be 30 pixels in, 10 from the top, and then it has gone on to point 9070, and so you can have as many of these points as you like. We are going to have 4 points, which will be this point top left, top right, bottom left, bottom right, but the way we're going to be describing it, we'll always need to say the x coordinate first, so it'll be left top, right bottom, left bottom. Okay, I always get confused with these kind of things. Question is, how do we work out what the x position is here on the left hand side? What is the x position on the right hand side? What is the y on the top and y on the bottom? So the way that we can do that is we can simply take the center position and subtract half of the width of the box, and we should be on the left line there. And similarly with the y, let's say the bottom, we should take the center y position and then add half of the height of the box. Okay, so I'm going to copy and paste this, and now we can explain it. So we're just going to, every frame, we're going to create 4 local variables inside the function. They'll get destroyed at the end, but we'll have used them by then. So every frame will create these 4 functions, left, right, top, and bottom. Again, you could call it magnifier underscore left or magnifier underscore right or something like that, but I'm just keeping it simple. So the left and right are x positions. This is left, the x position here. This is right, this is top, this is bottom. Okay. And the left position is the magnifier center 0, which is the x coordinate of the magnifier center, minus half of the magnifier size. Okay. Again, we might just do integer division here, just to be on the safe side so we don't get decimals. The right position is the magnifier center plus half the magnifier size. The top is the magnifier center 1, which is the y coordinate, minus the magnifier size, and the opposite. Hopefully you can see the pattern as it goes there. So just to be clear, if the left-hand side of the box we're drawing is 50 pixels in, then left should end up equaling the number 50. Okay? So what's our first point will be the top left. So that'll be up here. So it'll be the left x position and the top y position. So we can simply say now, left, top. And then the top right will be x first, right, top. In fact, for mine, just to make it obvious what's going on, I'm going to call it left x, right x, top y, bottom y, just to indicate these are x values and these are y values. So this will be left x, top y, right x, top y. So that's left x, top y. Okay, the next one is the bottom right, so that'll be bottom x. No, sorry, we need to go right. See, I'm glad I did the x and y, I was getting confused. Right x, bottom y. Okay, and if you'll see now, if we run it, we've created this border around the first 3 points, but we need to go to this point and then this point, so 2 more points. And also the color I'm going to change at this point to white, and maybe just 4 pixels wide. There we go, much better. So let's get around those last 2 points. So we want to add another tuple here, and this will be the bottom right. So we'll say left X and bottom Y. Check that. Good, we're 3/4 of the way around. And the final one is left X. Oops, I hit the wrong key. Top Y. Okay. All right. Maybe we might, I know breaking it in the middle of that, it doesn't make sense, but it's just a bit easier to see. Okay, so now hopefully you can see that that looks much, much better. It's much more obvious where the different edges, or where the edges of the magnifier are, and it's just much easier to deal with. One final thing, you might like to, instead of white, you might like to go to search Google for color picker, and you might like to choose a nice color that matches the color scheme of your picture. And then you can simply copy this hex value here and paste it in to quotation marks, and there it should work perfectly. I quite like that light green actually with my image here.